Okay, good morning and welcome. Like I said, thank you for joining us. Today's webinar, we're going to look at deployment challenges for private LTE and 5G networks. So just a quick introduction. I've got my colleagues online here. If you'd like to pop your videos on, guys, I can make those introductions. Okay, I'm joined today by Reese Robinson. Reese is Director of Business Development in North America. Thanks there, Reese. And also by Roham Alian. He's our Senior RF Engineer, and he's going to be giving our presentation today. Thank you. Today's event will run for about 45 minutes. We will be recording it, so you'll have access to that if you want to review it again, or if you want to share it with any colleagues. Well, before we start, I'll just give you a quick introduction to the ATDI group. So ATDI is a global leader in the development and implementation of wireless connectivity solutions. For over 3 decades, our solutions have evolved to meet the needs of spectrum users, responding to market changes and emerging technologies. We help network operators to manage and optimize their spectrum. Our spectrum engineering solutions enable dynamic spectrum access and allow SAS operators to manage frequency coordination, and users like the PAL and the GAA users to design their networks. We have offices in Washington, DC and New York, and we've got a global footprint of offices around the world. Okay, so today's going to be all about the challenges facing network operators. We're going to look specifically at key issues and reflect on our experience in this field. We'll be using a specific case study for the mining industry, but this approach has been used across industry and has application across many industries, including oil, gas, and utilities. ATDI works with some of the larger mining operators in the world. We support them with areas like network planning and modeling expertise. We provide them with software solutions, consultancy services, and customized training. This PowerPoint slide shows some of our major customers in the oil, gas, and mining industries. Okay, so today's presenter is Roham Alian. Roham has over a decade of experience in the industry. He's specifically in emerging technologies like LTE and 5G network design. Roham's going to be running through some PowerPoint solution slides today, as well as giving a live demo in our flagship planning product, HTZ Communications. HTZ Communications is an RF engineering tool which is used by regulators, network operators, and system integrators across the world. Okay, so just by way of housekeeping, all attendees today are muted. You'll have an opportunity to put questions to the presenter at the end of today's event. However, what I perhaps would recommend is you use that chat function in the very bottom of the screen. You can see that. You can drop chat messages, questions to me during today's event, and then I can put them to Roham when he finishes his presentation. Okay, I'm going to hand over to Roham now, and he's going to make a start of his presentation. Over to you, Roham.
Thanks, Sarah, for the introduction. And just to confirm if you guys can see my screen.
We can, thank you.
Okay, perfect. And thanks everyone for joining this webinar. In today's webinar, we're going to talk about the private LTE and 5G networks and see how to leverage the CBRS spectrum in private networks to meet the demands of high performance application, and look at the challenges on designing this type of network and using dedicated modules and features in HTZ software to tackle those challenges. So it's no secret that there is not much available spectrum left for the taking at frequencies which is best suited for wireless communications. It's either being auctioned off or owned by the government. So as a result, the government and the other cellular industries are looking for alternatives. So CBRS is one of them. In other words, CBRS allows 2 or more different services to occupy the same frequencies with the safeguard against the interference. So as we all see these days, the demands for industrial IoT application is growing, and these type of applications require high speed and resilient network. Wireless networks needs extended coverage and seamless mobility to support operation in some of the world's most dangerous environments. For the next slide, we're going to look at the quick history behind the CBRS, and I'm not going to talk too much about that because everyone already knows what CBRS is. But just a quick recall, CBRS is 150 megahertz of spectrum between 3550 to 3700 megahertz. If that 150 megahertz doesn't seem like too much to you, consider that a major wireless carrier uses about 130 megahertz for all its network combined. So it's huge spectrum and brings a lot of opportunities. So originally this band was reserved for use by the US Navy radar systems, but at any given moment, only a small fraction of available spectrum is being utilized. So it's the sweet spot in the spectrum which can be utilized better by many applications with respect to higher tiers. Speaking of tiers, CBRS is governed by a three-tiered spectrum authorization framework. So the first tier is the incumbent, which is the federal radar systems and has the highest priority. The second tier is a PAL or priority access license. And the third tier is the GA or general authorized access. So all the access and operations to CBRS are managed by a dynamic spectrum access system called SAS. So we are not going to talk about the details of SAS since that's not part of our discussion for this webinar. But what I would like to do is first talk about the private network and see like what does that exactly mean when we say private network, and how is that different from a public network? What benefits it will bring to the table compared to the public networks? Who are the potential users benefits from this private network? And then we'll see how we can take advantage of CBRS to establish this type of network. Technically speaking, private LTE and 5G networks work the same as the public LTE and 5G network operating by the mobile network operators. So the difference between the public and private networks basically resides in who has the license or the priority access to the wireless spectrum, and who owns and operates the networks-based station and other infrastructure. So for years, if an organization wanted to deploy a private wireless network at a factory, office building, or in other facilities, its options were only limited to Wi-Fi or other technologies like LoRa. But these legacy private networks were just enough to connect laptops to the internet and some other limited industrial IoT use cases. However, the coverage, capacity, and security limitation of this network, as well as their high ongoing management costs, make it difficult for organizations to use this network for many IoT applications. Private cellular networks that use LTE and 5G technologies have begun to be deployed by many companies and offer organizations that sets of advantage like better coverage, security, higher capacity, consistent latency, and other capabilities that they need for more advanced IoT application. In addition, the most important part is the long-term management costs for this network are often lower than the other wireless technologies. So CBRS enables enterprise organizations to build their own private LTE or 5G network, which requires interference-free spectrum and guaranteed service level agreements for network performance metrics like latency and throughput. So private LTE network basically allow you to avoid issues with the public internet, such as security, shared bandwidth, capacity issue, and you can enjoy the direct access to your private LTE infrastructure with increased security and control. But let's look at some of the environments specifically in mine and oil and gas field and see why is it important to have the private network in this type of environment and how this private network can help this type of environment to achieve their objectives. So in this slide, I'm going to show the challenges in the mine. So mine sites are located usually in remote areas with limited network coverage. And secure connectivity is always a challenge. Plus, autonomous mining and remote control machinery, which is the key to increase the productivity and working conditions, requires a dedicated and reliable network. So usually in this type of areas, the lack of wireless infrastructures makes the mine operators to think of having their own private wireless network with high availability, quality of service, the ability to support multiple applications and services simultaneously. LTE private networks are increasing rapidly in both underground and surface mining for connecting multiple applications and for improving the speed of automation. So we'll come back to this and I will show you the test case study in the tool. But another example I want to show you guys is the oil and gas field, where workers usually face a host of dangers like heat, confinement, elevation, and other challenges. And they need definitely reliable connectivity in case of emergency situation. And that's just an example of the demand for the robust network in this type of environment. So not enough subscriber makes the service provider not to likely want to build the infrastructure around this type of area. Plus all the pipelines and towers and other construction will result in lots of diffractions and attenuation, which makes it even harder to model the RF propagation in this type of network or in this type of environment. So even though the LTE coverage is usually excellent, but public network can struggle to meet the need of industrial deployment, where robust performance with low latency and coverage is critical. So when a company creates a private LTE network, it can monitor and control the performances by its need. So in addition, to onshore, the offshore communication solutions are also chosen because of the distance that the data must travel, the remoteness of the installation, and the amount of data that must be transmitted, as well as the availability of the network. So let's now talk about the RF modeling in this type of environment as an important challenge. So typically clutter-based propagation model where certain clutter heights and attenuation were assumed for signal propagation does not work in open mine or similar type of area. So using common SPM model will result in significant under-prediction at distance location. So this type of environment requires more advanced methods to calculate the attenuation considering diffraction and reflection, which provides better alignment with the real life. So modeling this type of environment is a big challenge. The next slide shows the study measurements that were collected in 2 different mines with different characteristics in terms of the terrain profile. So the first one characterized by 3 deep pits and the second one located on the hillside. So the result shows that the path loss for each mine was directly correlated to the profile and steepness of the mine. This will show the importance of the accurate GIS data and propagation model. So you can see in the picture here, the chart will show the character of each mine down here. And then as you see on the right side, the correction factor for the diffractions are different in mine 1 compared to mine 2, based on the profile of each mine. So now that we understand the importance of having an accurate propagation model, it's also crucial to know that performance of deterministic model is in an open mine environment depends on the accuracy of the train data. So with using 1 meter to 5 meter high resolution digital terrain, the deterministic model will be able to provide a fairly accurate estimate of the real-time path loss. As an example of performance comparison between HTZ communication, deterministic model, and untuned SPM model in one of the commercial trials in build-up area using the 2 meter cartographic data, the following results were achieved. So as you see on this chart, using the Daygood 94 and the standard subpath attenuation will improve the standard deviation, the mean error, and correction factor. And then using this model, you will achieve the more accurate result than SPM model. So in the next slide, I'm going to also show the different the screenshot from the different project, which shows the accuracy of over 90% using the HTZ propagation model. So you can see how is it important to use the accurate propagation model in order to achieve the higher accuracy. Okay, so now that we talk about the challenges, it's time to show how HTZ can tackle those challenges with dedicated features and modules. So as you see on this slide, an actual test case study that ATDI performed in the 5 years of RF plan for an LTE private network to identify the required numbers of fixed and trailer sites to achieve the 99% coverage across the pits and hauling roads. So the detailed scope of this study includes putting together the cartographic data, the equipment specification, antenna details, and etc. So also the antenna height were also assumed to be as followed for the fixed infrastructure, as you see on this slide. For the existing towers of macro sites, we are considering 60 meter. For the ski tower, we are considering 40 meters. And for the trailers, we're considering 9 meters. So the goal was to produce the LTE coverage prediction for each of the years during the 5 years plan for the UE with the height of 1.5 meter and minimum RSRP of -107 dBm. So I will show you this in the tool in a couple of minutes, but before that, I would like to also introduce our automation feature in HTZ, and then I will play a short video for you guys, and then I will explain on that how the automation works. But using the automation feature in HTZ, you can run the network coverage prediction and coverage analysis in an automated fashion. So this feature is essential when limited resources and timely manner process are put, and also saves significant amount of money. So the idea here is to integrate the tool into the third-party platform and define different tasks or jobs using our GUI interface and have them run in the tool on the background and deliver the result to you. So the point here is to automate the process with having the minimal interaction with the tool. So we are using the web-based API for this. And let me actually play the short video for you guys here. I probably need to pause a few minutes, a few times in the video and then explain. So here's an example where we have our network, and the goal is to define sets of tasks using our automation process and the GUI interface, and have them run the coverage and create the point-to-point mesh network. So as you see here, this is the final result. And then for this purpose, we are using the RESTful API, which is the web-based API. So we have the results showing on the Google Earth. We defined 2 links with the prospective server, the IP for the server, and this is the GUI interface where you can define your server, the jobs that you want to do, and then put them in the correction manner, like counting the coverage, calculating the coverage first, and then search the nodes to create the point-to-point mesh network. So you have to put the model, the legends, the vector that you want, and the train. So this will allow you to run the coverage and calculate the point-to-point mesh network without even interacting with the tool. So we'll see how it goes. After you select your server, the task you want to do, I will just fast forward this, and then the clutter type that you want to use, the model, the legend, and then as you see, I defined these three jobs or three tasks, coverage calculation, and then search the nodes for the point-to-point matrix, and then create our mesh network. So you can have you can put them in the order in the step 0, 1, and 2, and then each job has its own ID, as you see on the right side. Then you can go and submit the jobs or tasks, and then the tool will start doing that on the background. As you see, it says the jobs are received now. And then if you refresh, you will see that the coverage calculation started running. And then if you want to see it's really running on the background or no, you can see it, that the coverage is running on the background. So after that, it's going to move to the second task, which is searching the nodes, and then it's going to create the point-to-point mesh network. So after the job is complete, you can have the result to show in the Google Earth. So that's not the only platform that you can show. It could be any other platform. But for the purpose of this webinar, we just show that in the Google Earth, the result. And then as you see, the coverage is calculated, the points are searched, and the mesh network is created. So now I would like to actually open the tool, and we'll talk about the features. I just want to show you the features that we just talked about, actually. Let me stop the sharing here and start sharing the screen more. Please let me know if you can see my screen.
Yes, thanks. Great. Thanks, Roham.
Okay, perfect. Okay, this is the example of the oil and gas field. So using the high resolution database or the GIS database, as you see here, we use the 1 meter resolution for this project. So this will allow you to see any buildings or any towers in the 3D format. So really the high resolution is the key here. If you want to see the 3D format, let me show you actually how you can check the 3D format here. And then you just say 3D view. And then as you see, you can show or you can display the job or the project in the 3D format using the high resolution database. So you can also convert if you have any third-party or other formats of the map that you want to import it to the tool. There is a dedicated module in the tool to convert any type of data into the HTZ format. So it could be TIFF, BIL, or other formats, and then you can convert it to the tools format. So other features or other module that I would like to show here is our comprehensive propagation model. This will allow you, or this will give you the wide range of options to select from, which can affect your signal propagation based on the environment or the frequency you're dealing with. So this will allow you to select any propagation model from kilohertz range to terahertz range. So this is really wide, and there is lots of features and factors that you can select from to take into account once you're doing your propagation model. So for instance, you can have your 3D reflection and ray tracing based on the Lombardian or specular model. Or as you see on the right side, you can also take into account the attenuation by atmospheric effect, like snow, gas, dust, rain, and so forth. So down here, we also have some standard ITU model, which are for different frequency and different environments. And as you see, you can, using this propagation model, you can also model your indoor propagation model based on the different materials which was used on your project. You can use the model in the ITU standard model, or you can have the user define attenuations. So the next feature that I would like to introduce actually is our antenna pattern. So let me go to parameter. So this tab basically will allow you to build any type of antenna pattern, including omni antenna, MIMO antenna, panel antenna. And then as you see, you can use our online antenna library. Let me show you. Which has the most important or most famous constructors with different frequencies, antenna constructor with different frequencies and different technology. As you see, you can go to any of these and then select the pattern that you like, and then that will take effect here. Or you can build your own pattern by selecting from the predefined pattern, or just load any type of pattern that you have or is provided by you, by the customer. So that's about the antenna pattern. And there's also a possibility to import or export to and from the tool any different formats of the buildings or any different formats that you want to use in your project. Like for instance, in this project, let me quickly, this is the shape format that I have for my building here. So by just drag and drop in here, so you can have the building layer added to your project. So so this is the opportunity that you can import or export any type of the formats of the buildings into your tool or from the tool to any platform that you want. So as you see, these all these building layers is added as a polygon that was imported to the tool with the shape file as a shape format. And then you can make changes as you need to any of this by just going to the vectors. And then if you want to make changes, the colors or the names, you can do that. So back to our mine project, actually, the one that we were talking about to actually define different stations and location of the session for the search site. So the biggest challenge to design a private network in the open mine is the propagation and modeling the variables. So as a result of the transmitters and receiver constantly moving, so they cause a reflection, a scattering, and other diffraction phenomena. So add to that the train changes over the time. So with the dedicated module in HTZ Warfare, you can plan for example, for your 5 years RF plan with the dedicated module that we have. This will happen in 2 ways. So you can even do your search site by defining the polygon or the area of the interest and continue and do the search site. This will give you the heat map of the area and like the percentage of the covered area or the visibility that you want to see based on the selection. So let me complete this and you will see the result. Find the sites outside, and you can say, for example, maximum random points 50, and If I say okay here, you see that the tool is trying to give you the heat map based on the percentage that shows the visibility in each point based on your selection. And then the result, as you see, has different colors with different percentage. So if I put the station here, it will reach to 72%, as you see on the right side legends. It will reach to 72% of the visibility in that area. So let me just go ahead and, for sake of this webinar, I'll just add a station, random station here. And then you can see the site coverage, which is the visibility. Let's say for 2 kilometers. And then you can see all the areas that has line of sight or the visibility based on the location of the station that you selected. You can also read the path profile from any points toward your station by right-click and then read the profile. So you see in any points that there is a line of sight, the path profile will show you a clear path between the transmitter and receiver. Although if you go to the areas which doesn't show as a line of sight, you can also read the profile, but you will see that the signal were blocked by an obstacle. So this option will give you the opportunity or allows you to see all the line of sight areas around your station. Another features or another way of approaching this site search is to define subscriber in your area and then ask the tool to prospective plan that. So let me show you that as well. So let's say this is the area that I would like to study in my mining. And I will just draw a polygon around my area of the interest and then generate subscriber. You can even define the parameters for your subscriber. You can define the height, you can define the frequency, you can define the antenna type, the power, and so forth. So after you add this, you can define your database. For example, I call this test. And then I can use this subscriber database to search for the sites which can support this subscriber. So let me generate these subscribers. Okay, and then you can go to your list, database subscriber, and then set all these as an orphan, means that we still don't have any station attached to them. And then using the dedicated module, which calls perspective planning, you're trying to find out the best location and the number of the stations which can support these subscriber in that area. So you can select your number of the station that you want to deploy, the distance between them, the number of the sectors, and here you can set your objectives. If you want to reach to 99% or 95%, you can set the objectives here. So for this, I will just set it to 95%. So I will ask the tool if the not covered area get to 5%, stop the calculation. And you can select your subscriber station. You can even set your model, the propagation model here. For this purpose, I choose the DAGIT 94 and area. You can choose a standard based on the resolution. And you can even define your station parameters and ask the tool to calculate and show you the best location, the number of the station, which is best suited to cover those subscribers. Let me actually show this and then I'll pass to Sarah if there's any questions that we can go through. So if you go to subscriber now, and then if you want to see the path reliability or the power received in each point for each subscriber, we can also show that based on the different ITU model. So as you see here, this report will show me the power received in each point by any subscriber and the liability or the reliability of the path, which is 99.99 at this Sarah, back to you. If there is any question, I think now it's a good time to go through the questions.
That's great. Okay, everyone, thank you for that, Rohan. Really appreciate it. We have started to have a few questions come in. There were a few late joiners. I just wanted to assure you that we are recording to today's event. So if you did miss the first 5 or 10 minutes, don't worry, you can have access to that at a later date. One-to-one discussions, if anyone would like to have a demo after today's event, please do let us know. The guys are available to arrange that as well. Okay, so we've got a couple of questions that come in. First couple have touched on the propagation models. You showed lots of propagation models in a library. Do you have to purchase these?
So we call the HDZ all-in-one tool. That's why we don't charge per feature or per module. So our business model is to provide a tool which you can buy a license for and then use the 100% of the tool. So any features or modules which is available in the tool can be used by the license, and there is no separate payment or separate license needed for using any features in the tool.
That's super, thank you. Same goes again along on the propagation model. Is it possible to import your own propagation models?
Yes, the short answer is yes. And then we've helped a lot of customers around the world to come up with their own propagation model and then load it to the tool. We embedded those, some of those as the option into the tool as well. So the answer is yes, you can load or you can import your own propagation model to the tool.
That's great, lovely. Just as an example that we've showed, can we do mesh layouts as well?
Yes, absolutely. You can do the point-to-point or mesh network with your stations, or point to multi-point stations as well. Okay,
that's great. Another question here from David. What range of building penetration losses typically apply to modeling 5G coverage at millimeter wave? Say, for example, at 28 gigahertz. So that's the penetration losses typical when modeling 5G.
If I may share my screen again, I just want to show that in the tool. Is it possible to?
Yep, yeah, absolutely.
Okay, here in the propagation model, as I showed, we do have an indoor model, which is based on either the ITU model, and then depends on the type of the materials, the penetration losses or the attenuation based on the different materials will differ. And then you can have that as a user defined or based on the standard ITU model. So that really depends on the frequency and the type of the materials that you're using. And you can take into account for those in this part of the tool, the propagation model.
Okay, super. All right, we've had a question come in from Gary. It's about licensing and the versions that we have. So Gary, we release software versions throughout the year. Anyone with a maintenance contract has access to any upgrades throughout their maintenance contract. So yes, all of those upgrades are available to you, providing you have a maintenance contract. Okay, is the software suitable for simulation of broadcast services such as large antenna power or large antenna heights?
Yes, absolutely. HDZ, as we mentioned before, is suitable for any type of technologies, including satellite, earth communication, broadcast technology, microwave links, radars, and I can go down this list. So, but yes, absolutely. Literally, you can design any type of network using the HDZ.
That's great. Okay. The next question is about a SAP GIS option for gas networks, CAD GIS model. Do we have that availability?
I'm afraid I didn't get the last part of the question.
So it's a CAD GIS model. Is that compatible with our software?
I need to double check that with our support, but yes, we are mostly using the LiDAR, but for oil and gas project, we use the CAD GIS data as well. So,
that's
but yeah,
great.
I need to double check and confirm it.
Okay, that's lovely. So just to Santiago about he's completing studies in the C-band between fixed satellite services and 5G. They're using HTZ. That's great news. Pleased to hear that. We will be sharing today's recording, so you'll be able to have access to that. Okay, just moving on to the next question. Where are we? Okay, we have got a couple more. Import and measurement data. That's something we hadn't touched, particularly real-time measurement data. Is that achievable in HTZ?
Yes, absolutely. Using our import module, you can import or export any type of measurements, including stations and coverage, to and from any type of platform like Google Earth. So this is possible.
Super. All right. And then the last thing that we've had come up at the moment, and please do keep dropping those messages in, either use the chat one or you can use the questions and answer toolbar, is about data formats, GIS data imports. What does HTZ handle in terms of format for that?
We do have a converter module. I think I went through this through the webinar, but you can convert any type of third-party formats like TIFF or BIL or GRD to our HTZ format. So, or it could be LiDAR or another format. So we are basically supporting any type of format to convert it to our HTZ format. So using these features, the raster map convert. That's
great. Okay, we've had a question in here from Dana about indoor modeling. Do we have an option to import AutoCAD layers to show floor plans and various building construction materials?
Yes, we are using our ICS manager tool for that purpose, but you can import your CAD or AutoCAD maps or the indoor maps to the ICS manager, and then from there you can convert that to our HTZ format. Okay, so have we got any other questions? We've got, I think we're... And I just want to mention that we've done a lot of projects with some of our Navy customers where they had to model their ship or the aircraft carriers as the indoor model and then import that to the tool. So we've done that using the ICS manager. That's brilliant. Okay, just before we are open to more questions, I'll just do a bit of follow-up from that. So as I said, today's event will be available, the recording will be available after today's event. We will, when we finish today's event, just run a very short survey. It'll take literally 3 seconds of your time. If you could complete that, that would be really helpful to us, mainly because it helps us put together top content for our future webinars. So feedback is important. If you want to get in touch, that's a good way to get in touch with us as well. Okay, just going to check we haven't got any further questions. Otherwise, I'm going to say thank you everyone for attending today's event. Thank you, Rohan, particularly for presenting. And if you have any follow-up questions, please do get in touch. We're here, we're listening, reach out. We'd like to connect. Okay, thank you everyone.